Hey guys, today we're going to solve LeetCode number 1472, Design Browser History. So we have a browser when we start on a certain homepage and we can visit other URLs, go back in our history and go forward in our history. One tricky thing here is when we visit an URL and just before that we went backwards in our history, we need to clear up all of the forward history. So people have done this in the Discuss tab with various data structures, but honestly, the simplest thing you can do here is just use a normal dynamic array. And the tricky part is here when you want to clear all of the forward history. Well, using an array normally would take O of n potentially because maybe you have to clear the whole array. But honestly, why clear up the array when you can just set a variable that tells you the length of the array if you were to delete the forward history, but not actually delete the forward history. So yeah, that's what we are going to do. So we're going to store in our class the current history array, which starts with home inside of it. We're going to store also the current index in which we find ourselves in the current history array, which we are going to call current. And then we're going to store the bound of the array, which is exactly what I was talking before about. So this is the length of the array, the would-be length of the array if we had deleted all of the forward history when we visit a new URL. Okay, so now the visiting of a URL is going to have to handle the fact that we don't delete the history sometimes, and that's since we are adding a new URL, we need to move forward our current index pointer for one step. And then we just check if we went out of bounds of our history array, then we just push the new visiting URL to the history array. But if we are still in the history bound, then just overwrite the old element that was at this incremented index. So yeah, if we are not out of bounds, just overwrite whatever was here before, because if we went back with this.cur, it means that the forward history, so the one after cur, is no longer relevant. So just overwrite it. And now this bound is this cur, because this is the last element that we have inserted. So all of those elements after this.cur are removed essentially by doing this operation. But we don't have to pay the cost of actually removing them. Okay, now it's just a matter of implementing back and forwards, which are easy. You just need to remember not to go too far back or too far forward. So instead of moving current to just this.cur minus steps, we need to check that if this is negative, then we just need to move to the first index to 0 and then access this history at either 0 if this is negative or this if this is not negative. And we are never going to go further back than the history. So yeah, 0 is the correct minimum index here. And the same can be said about going forward. It's just that instead of doing a max, we're going to have to do a min. And instead of having 0 as our safe, as our guardian, as our sentinel value, we're going to use this dot bound, because that would be the pseudo length of our current array. And so that's the same thing, but using a minimum instead of a maximum, and incrementing the current by some steps instead of decreasing it, and using as a sentinel value the bound of the current array to the right instead of the bound to the left, which is always 0. And then just return the element at the current pointer. Okay, yeah, so this solution is optimal. It is O of 1 for every operation and O of n space, because on the worst case, what we do is we store all of the URLs. And I mean, the other solutions, like if you were to use a linked list, for sure you could delete the forward history in O of 1, but that wouldn't solve the fact that on the worst case, you would still be like, if somebody never went back and just insert new URLs, your space complexity would still be O of n. So asymptotically, in the worst case, it's still the same. It's still O of n memory. So that's it for now. Thank you and bye.